I'm now showing you something in testing Smalltalk web applications. My name is Carsten Härle. I run my own small company, consulting company, and I use Smalltalk since Smalltalk V, I think, and it's more than 30 years now. And I saw many Smalltalks, and this is one of the things I want to show you. So I showed you yesterday also this Benno product, which was used in schools. It will be in this case, and I will show it afterwards a little bit more because we use it for something else too. But the main talk about is about web application and testing it. And I just show you a web application which was developed from a Fed client. And then we developed some requirements which we needed to test this. The basis is this Selenium Parasol framework. But then we had a simplified layer, so to introduce test-driven development also to non-programmers, we wanted to have a simplified interface. Okay. The basic project is something for tax assessment and local taxes, local things that people have to pay. That it started as an Object Studio Fed client, and then it was transformed into a web application by keeping all the model of the Object Studio Fed client in operation, but that rendered it to the web. And for some years there was even both application running. You had the Fed client, and with the identical features, you had the web client. So the libraries are DHTMLX. Some maybe know that it's a very rich JavaScript library for web applications. Some custom control and some custom JavaScript. So here you see it looks like a little bit like a Fed client application. You have all these like a menu here, then you have tabs, then you have toolbars, list buttons, context menus, sidebars. So this looks a little bit like a Fed application. It was one. So also you have tree views and list boxes, searchable drop lists, everything we usually have in a Fed client application. So we had to test this for several browsers. It started to support Internet Explorer 6, which was not that easy. And then we have the problem with if you have AJAX applications, several things are rendered in the background. And when you start clicking, you click too early on something, the element is not rendered already, so it doesn't work. Then people start introducing additional weights programmed by hand, but this slows down your testing process. So we wanted optimal execution time and still have the framework wait automatically for non-rendered elements. And also to remove some of all this technology noise, so to make it accessible to non-programmers. Okay, I started with Selenium 1 as a base. I did the implementation my own, and then some other people implemented for Selenium 2, 3, and 4. This is called the Parasol framework, and this is just based on that. And I did 10 years ago, I did a port to VisualWorks. This was thrown out of the repository, but now I revived that, and I will publish it to the repository. So there is also a VisualWorks implementation available again. So, okay, then, as users like Parasol, the remote control architecture, WebDriver is going to phase that out, but it's still working, so let's see how long it takes when we have to switch to another interfacing. Okay, then I just simplified a little bit the Parasol classes, so that there are only 14 methods to implement to port it to another dialect. It was much more before. So, and the concept we have wanted to use also for the non-programmers is just we have always the same. You say Selenium and say action, and you give it a locator and a value. So this is quite something very simple. So you, for example, you say Selenium click on make order, or Selenium type, this is the ID of the element and value 5, or select country Belgium or something, or is element present. This is something, it looks like a script even to non-programmers, so they can use that. So the next problem is if you look at the locators, you can write it in XPath or in CSS or by ID, but it gets a little complicated. If you look here, you have lots of technology noise there, which is really not usable to programmers and not to non-programmers especially. And they also have this problem that you have dynamically generated IDs. So it doesn't work if you make a test case without. So you have to have a level of abstraction. So then we just say, okay, we make a layer above that, and we have this concept of list view, which is... Okay, yeah, whoops. Yeah. Previous slide. Yeah. One?
But there is no solution because, I mean, ID is so outdated, so you cannot use it because usually, so that predates components in web components, because as soon as you use components, an ID needs to be dynamic because you cannot have the same ID on the same page.
Of course, yeah. So you cannot help about these complicated things because it's not our library. It's generated from the HTMLX or from the library we used to build the application. So we are dependent on them. They are just generating them, and then you have to start, okay, navigate through the whole page and try to find the element where you want to click on, and then you have like the last one, very complicated XPath statements, and that you have to simplify that it can be used.
But still, this is from kind 10 years ago. So today, HTML is extensible. So the kind of attributes you can put in are custom. You can put there anything. So the framework usually that you use needs for testing purpose to assign reliability on something in order you can identify. There's no other way. So there is fuzzy. So you can go for XPath with fuzzy selectors like looking in something and find the closest outside, which removes the blurriness from if you change anything.
Okay, but I will explain it after the next slide anyway. So it's now, no matter how complicated it is, you have complicated XPath, CSS selector or something which are not usable which are not reliable and are not usable. So you have to find a way to locate the correct elements on the page, and therefore you just define abstractions for that. For example, we have this list view, and which I showed here before here in this. Here, this is just a list view which has headers and all the things. So, and when you navigate, it consists of hundreds of small HTML components, and with dynamically generated IDs. So then we just we say okay, but the user should only see list view and the list name, and then click on row 5, or the click on a row which contains some text. And then if you look at the XPath which is generated, it's really huge XPath statements. You have to go down that page, and you have to go a little bit up, and then you find the next element and click on that. So they can be very, very complicated XPath statements generated. So here, for example, okay, list view, you click on, normally you have your locator, you say give me a locator for the list view with named overview and the row 1. And then to make it even more simple to human beings, as you often click on list views, you just make a simplified syntax, Selenium click list view, name row 1. So then we have all defined all these complex interactions. For example, click list view and item label plus, and then you give all the paths how it should navigate through the list of from the root of the tree view through all the elements and just find the element which he has to open by just one message. Okay, so we have some sub-applications, so that's not really that interesting. So next thing is if I have a menu here, just a normal menu as I have a fact client application, and they are nested. So that's not that easy because if you move the mouse above the menu, then it gets displayed. And then you have to be very careful how to navigate to the correct submenu. But if you go just with a normal Selenium or WebDriver, it just goes the direct way. And if it goes there, then the menu is removed. So you have to just go in a rectangular way so that the menu doesn't remove when you try to click on the submenu. So this is also something, and we wanted to hide that too. So you just say click on navigation menu, and this is here. Just a hierarchy of submenus you want to reach, and then it tries really move the mouse, go rectangular. You do not go outside the menu, and depends on where the menu is displayed. That's the next problem. So you have to check how many space you have, so it doesn't go outside. So then the click wouldn't work. The next thing, sometimes it's not too deterministic when you have message boxes, and the message boxes are modal, like in a fat client application. Yeah, for example, it asks you something. Do you really want to delete everything? Yes, no. And this is a modal dialog box. We do a shadowing that the user is not able to click on any other elements. But WebDriver and Selenium is able to click on anything on the page, even if it's not reachable by a real mouse or by a real user. So we have to ensure this also. And to make it easier for the user, we just make, okay, there might be the next thing is a message box. And we just click message box yes on a message box which has the title order book or something. If we started with click message box yes without any title, but then sometimes completely different dialog boxes appeared, and it just clicked yes on everything, and the real path of the test case diverged completely from the way what we wanted to test. So therefore, we made it mandatory that you have to specify which is the label of the message box you want to click yes on. Maybe there's some typing error, and for it, it asks, do you want to format the head task? And you just say, oh, click yes all the time. That could be a bad thing.
Carsten, this means that before doing the action, you need to ensure that the app in the right state with the right element displayed. You don't have extra dialog or extra thing.
Yeah, you do something before just order. Okay, do you want to order? You say click on the order button. And then you know it will ask you, do you really want to order? And then you just like, well, yeah, click yes on that, but only if the question is the correct one. So then also we have the click toolbar button, click cancel, click print, click tree views. We have all these checkable tree views. Also drag drop. So this is a type of a test case. Yeah, you start by just log in, then click on the hierarchical menu, text type, doc text, doc search. and then it just types account number into the field which is named account number. Then it says, okay, click toolbar button, okay. Then it clicks on the first table row, and then it clicks on the edit button, because every list view has an edit button on it. So then we call it special buttons, where there are maybe 5 or 8 special buttons which can be attached to a list view. So, and this is the one which is named edit. So this is an example. And before we had that, then there was lots of many testers who were testing these applications by hand, and they wrote down these scripts in Excel tables. So we have to click there. Then you open this menu. Okay, it's possible to automate that, and then the people said, no, we are not programmers, we cannot do that. They bought actually a testing framework from I think HP or something, WinRunner or what's. It's very complicated for non-programmers to use, because they don't have these abstractions. And so it's possible for non-programmers to write test cases, and this is the way currently it works. So this is it's not really programming, it's just scripting like you do it in an Excel table or a manual clickable test case. So then there are some problems.
So on the previous, so do you think that we can generate that by clicking on the application?
Yeah. I had that at some point. With Selenium 1, it was possible to do that, but then you have to do some post-processing, and even then it was very complicated, because to find, you could intercept the click, but then you have to try to reduce this very complicated dynamically generated IDs and find this on your page and then translate it to the abstracted one. So I abandoned that, because it was getting more and more complicated when we had the more sophisticated UI frameworks. But ideally, it would be a good thing to do that. Yeah? Actually, it can be possible, because we could record it on the server side. Not on the website. So if you say, okay, start test case, and then start clicking, then maybe it's a good idea. I should try that maybe next time. So that the application of the server knows on the high level what happens on the UI. So you could start a recording, and the server records the test case. But it's not possible, I think, on the browser level. Okay, then there are some problems, because we have no page loads. It's just one page load, and everything is done in JavaScript with dynamic loading of sub-items. Then you have something which is going asynchronically. You do some, and then the page starts to render, and then some list is loading, then some other things are arranged. And if you are too fast, then you click on something which is not rendered already, then it doesn't work. So then we had to ensure that the page is fully rendered, and we didn't want to introduce manually wait, so just wait 5 seconds until the page is rendered. So this really slows down your test cases. So then we have injected JavaScript code, which especially looked at all the asynchronously happening things and watch them and give us a status when everything has been rendered, when all the data has been fetched from the server. And then we can immediately proceed.
Carsten, in WebDriver IO, there is something called wait for display, wait for enable, wait for something else.
Yeah, but yeah. Actually, we can use something a similar bit. The problem is it's too low level, because you just can wait on one element. But it doesn't know that after this is rendered, there will be extra requests loading additional things. So then there's a notion of when is your application ready, page ready, and then you have to program manually. So therefore, we introduced a single execute WebDriver, and then a single action could consist of several WebDriver actions, which are encapsulated into one. And we say, okay, this is, and then we check before. For example, this execute WebDriver, first check, is there an unexpected message box? Because as everything is rendered in HTML, WebDriver is not able to see that it's not clickable. Clickable is because everything is disabled. So you click something, and then in a message box appears which should not be there. But if the WebDriver doesn't recognize that, it just clicks on the on the elements beneath the modal message box. So therefore, before each command, we check if there are a message box which should not appear at that time. Then we execute the actual action, and then we wait for the actions and rendering of the page to be complete. And this is for every click and every single key which is typed. So, but this is quite slow because there's lots of communication between the server and the test case. So there's an optimization. The optimization is, but only do that if it's not a read command, because you have several things you do on the test just. Is this selected? Is this editable? Is this disabled? So you don't have to wait for any additional things because it doesn't change the state of the web application. So then it's just an optimization not to do anything if it detects that it's a read command. I don't go, so then, wait screen, yeah. Okay, with the message box we also have this, there might be a message box, but maybe it doesn't, it's not displayed, so you can also have this thing, click message box if present. So, input fields, there are some custom input fields which are no real input fields with just JavaScript, HTML, and they work like input fields, but they are no input fields. But we want to treat them as input fields from the higher level, so therefore you have this extra special handling of the notion of it is editable, is it disabled, is it can you type something into it? This is all special Java code, but on the user level you don't see it. You just say type name of the edit field and the value, and you don't really recognize it's a custom field or it's a standard web HTML input field. Then the next problem, you have dynamic list loading. So I think many people know that. If you look here, it's a very big list, and if you scroll, it's dynamically loading additional elements from the server. So, but if you do that and just click on something and the rendering has not been finished, then the test case will fail also. So yeah, you have, and the next problem is it's only partially rendered, but what you don't see is not there actually on the client. So if you want a list box and you have 1,000 elements, but it only displays the first 20, and you just use normal WebDriver, it always fails because all the elements which you don't see are not there, physically not there on the browser. So therefore, you have extra functionalities. Okay, look, it's try to scroll to the right position, so it's displayed, it is rendered, and then click on it. So. Yeah, same with drop lists, which big drop lists, they are actually physically empty on the browser side. You just cannot say just to select a special some item from this list box because it is empty, and as you start typing, it gets filled from the server. So you have to ensure that if you just want to select something, that it loads what you like to have. Also, a problem with WebDriver is what you don't see, and even if you see it only partially, we have, for example, list boxes where you see just half of the line because of the scroll bar. Then WebDriver is not able to click on that. So you have to scroll it so it's fully visible, and then you click on it. Next thing is there are helper applications for Chrome and Edge, which are executables, which you have to load before, and they depend on version. And as Microsoft, for example, is applying updates every day, and you have 20 or 40 or 100 machines, they all have different versions in the minor level. So we implemented some code that how you can to detect the exact version, load the exact helper executable, so that the test case get executed correctly. So then I just show how much time I have. Okay, so this is here an example of how the web plays. I have lots of test cases, now it started, and okay, it's not magic, you see it, I think, from many other applications. So this is a combo box, which is actually empty, but when you start typing, it fills. So this is just also a test to test this combo box, therefore it does it key by key, which is quite slow. And the other thing you saw is just it enters the string at once. But here in this combo box, it does it key by key. Okay. So just I showed you the dynamic scrolling and also the problem of resize. If you look here at the low level, we implemented something that you use the browser. The people don't want to have vertical scroll bars. So we implemented something that the last list on the website extends to the whole space which is available on the screen. So this is a very low resolution, so therefore you only see 4 lines now, but usually it's much longer. But you see, if I change the window, you don't get additional scroll bars, but it just, you get, if you make it smaller, you get scroll bars. But if I make it large enough, they will disappear. So that the user usually don't need vertical scroll bars. And it's not that easy because you have a scroll bar in the browser and you have a scroll bar in the list box, and this confused users and they really complained, oh, we don't understand all these scroll bars on the application. So we started eliminating scroll bars by just dynamically calculate how much of a list fits into a page. Okay, so. Yeah, one interesting thing is because if you run the test cases, and actually everything is Smalltalk, we run when we run it on the server, which is our development environment. Usually I click to have a black box text test to click where I click on the browser to simulate a real user. But sometimes it's very difficult to find things on the browser. So, but as the server is running in the development environment, I can go into a test case here. This is black box until here. It clicks with WebDriver or Selenium on the outside. But then you just say active controller, and then you get to the Smalltalk object in the test case. So this line is running actually on the server side. If you're in a test case, it opens the browser and then attaches has a dictionary. So if in a test case, it knows which window it did open, then you say active controller and you get the controller object and can ask anything with just normal Smalltalk code to inspect what is the internal state of the object, which for example might be not displayed on the web page. Some information is displayed on the web page, but you really want to check it exactly. It's a whole state correct. Then you just say active controller, inspect the object, and make some assertions directly on the Smalltalk object on the server side. So then we did a continuous build and test. So this, the people from LiveWire even used much more processors. We only have 50 virtual machines, which do just constantly loading everything and testing all the test cases for different browsers and also different databases.
Question: How many? What's the number
Yeah, this is this picture. So the number of tests is 3,600. It is just it's almost all, everything is UI test. Oh, so I've come to an end. So this is the application. The interesting thing is here. Unfortunately, web testing and UI testing is not that deterministic. You execute a test case 10 times, and it's perfectly okay, and it fails 1 or 2 times, but 8 times it works. So we have to deal with that too, so that we make a notion of past, a little bit past, more past, totally past. So you see that here, for example, this is a dark green, which may, okay, oops, this is really past. But then if it's a lighter green, you see that here, okay, it passed most of the time, but in the last 10, there were 3 failures in the last 10 ones. But this, we consider it light green. Then one task is to get rid of these undeterministic behavior, which is why does it fail sometimes, and if your test case which fails every 100th run, then it's no problem, but if it fails at 50%, then it's a problem. So we try to push down the failures, but also we cannot run everything. It just says, okay, it failed, then it automatically restarts and tries again on another machine, and if it works for 3 times, then it say, okay, it's green. Okay, then, yeah, we also used it because it takes a couple of hours to finish all that, and we use it also as an assignment, because if a web test case fails, the question is who has to fix it. So we said, okay, this is the test runner. We can you see which test case are, which are the results, which on which platforms do you have the execute, and you can just look at the history. All test case executions are written to a database, so you can really look at the history, and you see how many failures and past results you have. And also you can go in the UI and say, okay, this is a test case, and you see here which is the author, who originally created the test case. This we just query from the source code management system. Who's the last one who created that? And then you can just say, right-click, assign this test case to someone else. I know someone in the team, he is a specialist for that test case. He should be able to fix it. And you assign it to him. Then when he opens the test tool, he says, okay, someone else assigned you some test cases. And he gives a comment what the other colleague said, thought about that, why he should fix it, and why I have to look for it. So there's a small ticket system also, because it's very, very easy, just one click. Okay, you see it fails. Can I fix it myself? Otherwise, do I remember maybe who can fix it, and assign it to them, and you get an email and look at the test case and fix it. So then one thing, the last thing is how to, so this is also the product I misused, which actually for school I showed you yesterday, but we also use it to steer all these virtual machines. And the problem is if you have a virtual machine and then something goes wrong, it starts opening browsers and browsers, or it's eating up all the memory. You get these memory exceptions from Windows, and then also your application crashes, so you're not able to restart it. So then we have a service that we can use that. For example, we have a certain version, then we start all the, I ask who is running this version. Then you can look at the machines, what are they doing, just by looking here on the screens. I can also, and then I can also say, okay, there are some problems, I want to restart it because they're not responding anymore or something. So then you just can say here, terminate everything on the remote side. So just kill all the processes, tidy everything up, and then you can say, okay, I want to restart it. You saw here, it's like, okay, I click on the version, click on all the machines and say, start this version on this 20 machines from scratch. Okay. So I think this is the end. Thank you. So any questions?
Yes, I have a couple. First of all, what's the average reason why these tests pass sometimes and then fail other times? Do you have any, the top 3 reasons why this happens?
Yeah, actually, this is sometimes has to do with this dynamic behavior. Sometimes the way we implemented the waiting for the rendering was not perfect. It works in 99% of all cases, but there's a special case where we are too fast and we click too fast. Sometimes simply the browser crashes. Sometimes there's some other malfunction of the application that it eats up memory and the browser gets an out-of-memory exception and then everything stops. Or Windows crashes. And before Windows is really crashing, the application which, for example, wants to have some more memory or wants to open Windows, the Windows call start failing. And you cannot open a browser anymore, or just you want to click something, you have totally strange behavior. That's not possible to click on elements on the browser because something went wrong with the whole system, and then you have this a little bit undeterministic behavior. The question was, what is the top reason? What are the top reasons for undeterministic behavior and test cases sometimes working, sometimes failing?